Hey there, in this video I will be discussing about linked list. It is a most important data structure and it is a linear data structure. So we will starting with, so let's get started. So basically this is the definition of linked list. So what is the definition? So linked list is a linear data structure where elements are stored in nodes. So before that we have studied about arrays. So in array, how data will be stored. So let's suppose this is your array. So basically in array, data was stored in a continuous or contiguous memory allocation. So that's how things will be working. But and this is also a linear. So linked list is also a linear, but the elements are stored in nodes. So I will be explaining in this lecture how things will be working. So and each node. So basically there is a node. Let's say this is the node. So in node there are two things. First thing is the data which I have written over there, and another is next pointer. So next pointer is pointing, so this node is pointing to some another node. So that's how things will be working. So that's how things will be working. So there are some types of linked list, which is singly linked list, doubly linked list, and circular linked list. So as the name suggests, singly linked list means one node is connected to another node is connected to another, and that's how things will be working. And doubly linked list means this node is connected to this node, and this node is also connected with this node, and that's how things will be working. And what is circular linked list? So this is like this is a node, this is the another node, and this is the another node. Okay, so this node is connected to this node is connected to this node, and after that this node is connected to this node. That's how a circular kind of things is being developed. So that's how this is a circular linked list. So what is the structure of a node? So that's how I was explaining in this previous slide. So this is the node, and this node A is pointing to the B node, and this B node is pointing to this C node, and C node is pointing to this D node, and this D is pointing to null. It means that D is pointing to nothing. So this is the code that struct node. Struct node means this is a structure type of data type, and this is the node. These kind of things is node containing two things. First one is the data, and another one is the pointer. This pointer is pointing to the next node. So that's how it is written. This is the int data, which is the data part, and node star next is pointing to the next node of this okay, so pointer to the next node. So that's how this is the structure of a node. So let's move forward. So why we oftenly use linked list? So first thing is dynamic size. So means you don't need to know what will be the size before initializing. So you can change your size based on your requirement. So unlike arrays, the size are not fixed. So in array, whenever you want to define an array, you have to give the size of the array also. So but here linked list, you don't need to do all those things. And efficient insertion and deletion. So basically whenever you want to insert something in array, then it will be taking O of n time, but here it is taking O of 1 time. How it will be taking, I will be explaining in this video session in this playlist of linked list, how all those things. And another thing is memory utilization. Basically it is not storing your data in continuous way. It is storing one data is at this point, another data is another point, another data is another point. So that's how we can manage our memory more efficiently. So memory utilization is perfect in linked list as compared to arrays. So we are just comparing with array and just find out how things is working. Okay, so what are the disadvantages? So basically the disadvantage, the first disadvantage is higher memory uses. So how how it is basically memory is taking higher. So basically it is taking a pointer. So pointer, additional pointer requires extra memory. So in arrays there was no concept of pointers, but in every problem of linked list you take a pointer, and this pointer requires extra memory. So this is also taking off one space, but it is taking. So that's how it has been written. So sequential access only. In array you can access any element. If you let's say this is your array, and this is, let's say, your element. You can access any kind of element. If this element is present here, you can access directly O of one space. But in linked list, sequential access possible only, means that if you want to access this memory, then you have to go from here, then here, then here, then you can basically go to this point of address. So that's how things will be working. So complex implementation, this basically require requires more effort compared to an array. So basically it is quite complex. If you write code on linked list, then you find something harder as compared to array, but it is not so much harder. It is easily understood by you, but as compared to array, it is quite difficult. So let's move forward. So what kind of operation you oftenly used on linked list? So let's do all those things. So first, traversal. You can traverse a linked list. So how you traverse? Visiting each node, process the data. So you can process each node. Okay, so that's how things will be working. Okay, and insertion. So what are the insertion? You can add a node to its beginning, or in between nodes, or at the end of the node. You can insert. You can delete, same thing, that you can delete this first node or last node, or between any between first to last, you can delete anything. You can search, you can find that is this element present in the list or not. So that's how these are the four kind of operation that can be done by a linked list. Okay, so here is an example how to create a linked list using this code snippet. You can easily understand that I have created a node star head. So basically head is a node, and this node is pointing to nothing. It means that it is initialized with an empty list, means that this is sort of this kind of thing. It is pointing to nothing. That's how. So now I have a node star new node. So basically I have created a new node. Okay, and this is a constructor call like new node. So that's how things is working. And in new node I have to insert some data. So new node, and this kind of symbol is basically used to assign data. So in new node, what will be happening, there is example, this is your new node, and this new node having two part, one is data and another is the address of this data. So the data part is 10. Okay, this is the new node, and the new node next pointer is null. So this pointer will pointing to nothing. So that's how the overall thing will be working. And the pointer of this head is pointing to this. So means that this head pointer is pointing to this new node. So you can easily see how things is working in this slide. So this is all about this lecture, guys. If you really like this kind of explanation, then please like this video, and definitely you should subscribe my YouTube channel. Thanks for watching this video. Till then, goodbye.